here in this example, I have an equation and I want to find all the pieces of information about the graph, particularly the focus, vertex, and directrix, but ultimately we're going to need a couple other things in order to get the graph figured out. The ends of the lattice rectum, the axis of symmetry, maybe even some intercepts if they work out okay. So I have an equation here. Now this equation looks nothing like any of the forms that we've seen for parabolas. One thing I noticed though is that the x is the variable being squared. If the x is squared, then this parabola is either going to be opening up or down. Remember, it opens in the direction of the linear term. Now there is a linear x term as well, but it's the term that is not squared. So we're going to be opening up or down. I won't go too far with that at this point. Let's see. But because it's opening either up or down, the equation that I need to put this in, the form of the equation is going to be x minus h squared equals plus or minus 4a times y minus k. I would like to get it in that form. Now the h, the k, those might be 0. We don't know yet. We'll work on that. There's a trick to this. What I really need to do is separate off the two variables. Get the x's on one side, the y's on the other. That'll be my first goal. So let's go ahead and start with that. Separate off the x's and the y's in this equation, because I want to eventually sort of mold this equation into one in this form. Okay, so from here, I'm going to add the 4y and subtract the 1 from both sides. Okay, x squared plus 6x will equal, I'm going to leave a little space here because I need to work with that for a moment, 4y minus 1. Okay, now if you'll remember, you may or may not recall this skill. It's called completing the square. What we're going to do is we're going to try to create a polynomial here that will factor into this form x minus h squared. You may recall a formula, we call it the perfect square trinomial formula, that says you have a quantity a plus or minus b squared, it expands into a squared plus 2ab plus b squared. Potentially you might recall that. And so if you have a polynomial, a trinomial, that fits this form, it factors into a sum squared, a binomial squared. And so what I want to do is create one of these perfect square trinomials on the left side so that I can factor it to look like this, right? That's the goal. And so to do that, what I need to do is I know that the x squared and the a squared match up. I know that the 6x matches to the middle term, the 2ab. And so what I need to know is what this other term is. Okay, so if you imagine the 2ab being equal to 6x, the question is, what is the b? Well, the x and the a correspond, right? Because a squared was x squared. So I don't really need the a and the x. Those are the same. So 2b equals 6, which means that b must equal 3. A really quick shortcut to this is essentially cutting, you divide the 6 in half, right? Divide out this 2 to get the 3. And then you take that b value, the 3, and square it to get the other term. So I take this 3 and I raise it to the second power, and that will give me a 9. It's a 9 that I need to add to this side to complete the square. I'll do that in another color so you can see it. So I'm going to add 9 there on the left. But I can't just randomly add a 9 to the left side of an equation without doing the same to the right side. That's our addition property of equality. And so I'm going to add a 9 also to the right side, right? Add the same thing to both sides of the equation. Now I'm going to simplify. This left side factors using that perfect square trinomial formula. So I have a plus b quantity squared, or a plus b, I'm going with the formula. I actually want the values in there. So it's going to be x and 3. Those are my a and b values. So it's x plus 3 quantity squared, okay, equals, now I simplify the right side, I get 4y. Now actually 4y, this will be plus 8, right? And before I actually write it out here, you might notice that there's a common factor of 4. In order to get this to match up with our formula, I really need y to have a coefficient of 1. And so what I'm going to do is factor out whatever the coefficient of y is. It doesn't even have to be a common factor. If this was a 3y plus 8, I'd pull out a 3, and I'd have 8/3 here, right? So whatever it is, I just need to make the adjustment. Here, it's nice because it is a common factor. I pull out the 4, and I'm left with y plus 2. Okay, divide the 8 by the 4 to get the 2. All right, and so now I have my equation in this form, and now I can pick out all of the other pieces of information from this, primarily the vertex. The vertex is the key thing, and that's at h comma k. All right, so I know that the vertex then is going to be the point -3, -2. Right? That just comes right off of that formula. The other thing I need is the value for a, because a is what gives us, not that a, the a in, not this a here, the a in this formula. That a gives us the distance to the focus and the directrix from the vertex. All right, so in this case, the a value is going to come from this leading coefficient, and that coefficient being 4, well, if I set 4a equal to 4 and solve for a, you'll know that it's just 1, right? So the a value here is simply equal to 1. That's very critical. I also know that since this is positive, that value is positive, so that implies that the graph will be opening up instead of down. Okay, so positive opens up. All right, so that gives me some information. That tells me that from the vertex, the focus will be above and the directrix will be below. Okay, so now let's actually try to plot this graph. I don't need too big of a scale here. I don't need a lot of values in each direction. The vertex is at -3, -2. Maybe let's move this to, let's see, maybe 6 in each direction. 6, -3, and there's 6, and 3, 1, 2, 4, 5. And let's go 6, 3, 1, 2, 4, 5 roughly. -6, -3, 1, 2, 4, and 5. That's pretty good. Not going to be perfect, but I can make some adjustments. And so my vertex is -3, -2. So that would be right there is our V. Then the A value being 1, I know this opens up based upon the variable that has a square and the positive coefficient here. And so if the A value is 1, that means I need to go up 1 to get to the focus. That would be right there. So the focus then, F, put this over here. The focus is at the point, what's that, -3, -1. We just went up 1 from this point, from the vertex. And then the directrix is going to be down 1. So the directrix, if I go down 1 from there, that puts me at -3. And so I've got to subtract 1 off of this -2 value, And that puts us at y equals -3. Okay, so there's our directrix. Put a D on that. Okay, and then let's see, what else do I need? Oh, I need each end of the lattice rectum. And we know the lattice rectum to be 2a in either direction. L-A-T-I-S. I keep spelling that wrong. Lattice rectum. Okay. The ends, again, they're going to be 2a. So plus or minus 2a is just going to be plus or minus 2 because the a value is 1 again. And so from the focus, I need to go 2 values or 2 units in each direction. So from -3 here, I go over to the right 2 and over to the left 2. Of course, I could add or subtract 2 to the x value of the focus, and that would give me a value of -1, -1, and -5, -1. Okay, so -1, -1, -5, -1. Okay, so that gives us our 2 points, and of course -1 to -5, that is 4 units apart, which 4 times 1 gives me the total length of that lattice rectum, and that's exactly what we're looking for. So we have the vertex, we've got our 2 points. Also my axis of symmetry, that'd be good to note as well. And the axis of symmetry goes through both the focus and the vertex. It will be a vertical line because this does open upward. And so that axis of symmetry should be at -3. So that's x equals -3. And that's everything except the actual graph. So I should go ahead and plot that. Again, I could find the x and y intercepts. The x-intercepts, you set y equal to 0 and solve for x. If I put a y equals 0 in here, I get 2 times 4 is 8. This side is 8. Take the square root, you get plus or minus √8, which is 2√2. And then you subtract the 3. So the x-intercepts, without writing all the details out, would be, what did I say, -3 plus or minus 2√2. That should be the simplified form. Of course, you'd want the decimal values there to be able to actually plot them on the graph. And then the y-intercept is where you put a 0 in for x. You get 3 squared is 9. Divide out the 4, you get 9/4, and then subtract the 2. 9/4 minus 2 is 1/4. Sounds about right. So it'd be 0, 1/4 would be the y-intercept. 9/4 minus 2, which is minus 8/4, is 1/4. Yeah, okay. That would work out. So 1/4. And that kind of makes sense from the graph, I guess. If I were to draw this in, it does look like that crosses around 1/4. And on the other side, it also goes up to the left. All right. Now I'm not going to plot the x and y intercepts right now, but you could do that if you needed to get a little bit better view of the details of this graph.